On this video we will be seeing a little bit more about how to use tuples in our Python code, and then we are going to say a few words about named tuples, which are a special type of tuple. First of all, we will see how to use the packing and unpacking of tuples. We have already seen the packing of tuples, which is when we define a tuple as a list of variables separated by commas, a sequence of variables separated by commas. When we print that, when we assign this list of variables separated by commas to something, then that automatically gets packed into a tuple. That's called tuple packing. And here we can see that I get a tuple of my three elements, 3, 5, and red. When I have done this, we can see it running here. We can also undo it. We can unpack. If I have something inside of a tuple, my tuple T now contains these 3 elements, I can also assign them to different variables. For example, first number, second number, and string is going to get T, and I have assigned to each of the fields in T one different variable, and then when I print them, I get again the 3, 5, and red values of the 3 fields of the tuples into 3 separate variables. Here we were packing into a tuple, here we are taking a tuple and unpacking it. This, as we will see in a second, is going to be useful in some Python loops. Let's see a little bit more how to use tuples in our code before we get to the packing and unpacking in loops, revisiting one example that we had already seen. Okay, we have this random in list function that used to generate in previous units lists of random integers for us. Okay, so as you can see, we have a definition of a function here with its return statement, and we have a for here where we have append, and we have a call to the rounding function. This generates a list of random numbers. Going to first create a list by calling this function, and a random list is going to contain a list of random numbers, and I'm going to see it printed. This is a random list that I have created, and these are the random numbers in my list. Now we are going to make a single loop that traverses these elements. Okay, and we are going to have a simple loop here which appends, as we saw before, either true or false to a list of Boolean values depending on whether each of the positions in my integer number list is bigger or smaller than 5. Okay, to be precise, is bigger than 5 or smaller or equal to 5. And this is what I'm doing here. I'm appending and I'm creating a list of Boolean values. In this new version of the code, I have used something called zip that takes my 2 lists, the random list of integer numbers and the Boolean list that I have created in this loop, and zips them together. And zipping them together means that it creates a new list that at each position contains a tuple, and each tuple contains 1 element in my 2 lists. I can do this with anything that's iterable. They don't have to be lists, and I get a list of tuples. Okay, and at each position I get the original value in the random integer list and the Boolean value that tells me whether or not this is strictly bigger than 5, and 0 is not, but 6 is, 3 is not, 7 is, 6 is, 8 is, again, and 3 is not bigger than 5. And with this very simple code, I have been using lists quite a lot, I have been using loops, and here I have been using tuples along with my lists. This is one of the uses of tuples with lists in this case, and here we can see a simple use of tuple unpacking. Taking the list that we had before, we are now going to unpack it again. we are going to be traversing my list of tuples, which I have printed first. The list was this. So at each position I have a tuple, and now I'm going to be something that starts by unpacking this tuple. For each tuple, number and Boolean value is going to be unpacked from the position in the list of tuples. So each of these tuples is going to get unpacked into two variables. The first one is going to be called number, and the second one Boolean value. And then I'm going to be printing only those where the Boolean value is true, as you can see here. 677, 6887, and I'm ignoring the 0 because the Boolean value is false, the 3, and that other 3 there. Okay. That was tuple unpacking. And notice that I can make it a little bit more compact. Okay. I can make the counter line a little bit shorter, and I can eliminate some of the assignments. I can do my tuple unpacking directly in the for body instead of doing tuple here and then unpacking the tuple in the next line. I can directly unpack in the for line. Okay. To finish this lesson today, I'm going to speak briefly about named tuples. Named tuples are a special type of tuple that are imported from the collections library. This way, collections name tuple. Okay. And basically they are tuples that build on this idea that I'm going to use tuples to represent some sort of complex data, made up of different parts, by allowing me to access those parts using a name. So now I will have tuples that I can access using the position of each field in the tuple as I've been doing, but now I can also assign a name to each of my fields. So for example, here I'm going to have a definition. I'm going to have a new tuple that's going to be called person, a name tuple that's going to be called person, a new data type that I'm defining, and here I'm going to have this syntax where I'm going to be invoking this name tuple function, this name tuple class actually, for those of you who know a little object-oriented programming, and I'm going to give it the name and the name of each field. Notice that I'm not giving here any information about what data might be there, about types or anything. I'm just giving them names. Okay. And then I can instantiate, I can create objects, I can create variables with this person data type by giving them values for each of the fields that I have named. For example, I could create a person that I will put in a variable called Bob, and this will have a name, which of course is Bob, an age, and a gender. And I can print that. Let's see this in the Jupyter notebooks. Okay. We can do the same thing, but let's now define another name tuple, which is a point 3D, a 3D point. Okay. We are going to call it that, and then of course my three fields will be X, Y, and Z. In order to define a point, I have to use the name of the class, and I could either give a name and a content for each of the attributes, or I can do it using a general tuple, and then they will be assigned in order. In this case, X is going to be 1, Y is going to be -2, and Z is going to be 0.1. And when I print it, I get exactly that. I have tuple, and my names have, my attributes, my fields have labels. Okay, I can then access those attributes, those fields, by name, the names that I have defined when I have defined the name tuple type, or by position, as I was doing until now. Name tuples are one step more in this direction of using tuples as basically a way to define classes. Then what I would have here is similar to the class definition, only focused on what the attributes of the class are. And then I would have here what basically amounts to a call to the creator, and then I have the access of all the attributes. All of this is, again, object-oriented programming, in which we will delve much more in a further course. To finish this session, we have seen tuples today. Tuples are used to mainly encapsulate and express complex ideas made up of different types of data. They are sequences in the sense that they have different fields that I can access directly, but their semblance, their similarity to lists ends there. In list, all of the elements have the same, they have one position in the sequence, and that's very important because that's what lists are for storing and accessing very easily sequences. Tuples are just there to encapsulate to group different values together. Because of that, lists have to be mutable, but tuples are like most types in Python, and they are immutable. I cannot change it if I cannot change them. If I change one value in one tuple, I get an error. We saw how to use tuples inside of Python loops using these packing and unpacking instructions that are very comfortable in some loops. And we have seen how this idea of representing complex ideas made up of different parts, can be taken one step further using name tuples that allow me to give names to each of my fields, of the fields in my tuple.